How's it going, AngularConnect? How you guys doing? Good. It's been an awesome day. All right. Well, as Ed said, I'm Alex, and this talk is called Advanced Angular Concepts. So I'm a software engineer at Google, and for the last 3 years, I've been a member of the Angular core team. And so on the team, most recently, I worked on our HTTP client implementation. That's the Angular Common HTTP API, which is stable in Angular 5. And it supports a number of advanced features like interceptors, which we're going to see today. And with 5, I also launched our service worker implementation. That's something I've been working on for a long while. And that makes Angular applications faster and more reliable across flaky network connections. Service workers are a part of our progressive web app story, which is something that I've been very passionate about and that I've talked about at other conferences, including last year at Connect. But today we're going to do something that's completely and totally different. So occasionally I go to these events and I talk to people, and I also am pretty active on our community chat on Gitter, which is a great place to just meet other people in the Angular community. And sometimes people pose questions there, like how do I design this thing with Angular? And I've often found that some of the more elegant answers utilize lesser known portions of Angular's APIs. Not necessarily things that are complicated or complex, just things that your average developer doesn't encounter on a day-to-day basis. And so that's what we're going to do today. We're going to dive into a few of these cases and learn how we can use Angular APIs to design better developer experiences for the services and the components that we create and share with others and that we use ourselves. So we're going to do this with 2 abstract goals. The first is to learn how to configure services and libraries. And the second is to learn some interesting ways of communicating between components that go beyond just simple inputs and outputs. But rather than explore all of these topics abstractly, we're going to consider them in the context of 2 design challenges that I've seen come up in the past. And the first is to build a retry interceptor for HTTP client that takes its configuration from the consumer. And this is going to be our example of how to design a module or a library for configurability and for reuse. It's going to allow a configurable number of retries, as well as specific retry limits for individual domains, because not every service that we depend on is as reliable. And the second thing we're going to build is a wizard component. And that's going to be our example of intercomponent communication. A wizard is just an orchestration component that displays the sequence of steps to the user and moves them through them. And those steps we're going to try to decouple as much as we can from the wizard itself. So we have 2 topics on our agenda today: dependency injection and queries. And we're going to talk about them each individually, and then I'll show you a really awesome way to combine the 2. So let's go ahead and jump straight in. So dependency injection. It's not that new of a concept in computer science. It's very popular in a lot of back-end frameworks. Spring for Java, and Google has their Juice implementation. And in fact, AngularJS was one of the first JavaScript frameworks to implement DI in the browser. And Angular improved that a lot by coupling it with TypeScript. Right? Types and dependency injection work very well together. And the main goal of any DI framework is to separate the concept of depending on something from the knowledge of how to construct it. And so with DI, we don't have to know how our services or other dependencies are instantiated. We never call new ourselves. We simply ask the framework for an instance that someone else has configured for us. And that decoupling of dependency from construction is one of DI's many benefits. So additionally, it also decouples interfaces from implementations. We can depend on the API of something without necessarily knowing what implementation we're going to get at runtime. And DI is an excellent mechanism as well for packaging up a complex service or a set of services and publishing them in the reusable fashion. So for example, how many people here have used Firebase? Right? Awesome. Keep your hand up if you use Angular Fire. Yeah, cool. Angular Fire is actually a fairly complicated library internally. But as a user, it's relatively simple to use because it comes with just a couple modules that you just drop into your application and configure. And that's thanks to DI. And finally, DI is very important in testing. Right? It's what allows us to test components in isolation by mocking out their dependencies. And so we don't have to bring up entire applications to test one small part. So the first thing that we're going to do, and use DI to do it, is implement an HTTP interceptor that will retry requests. And that itself is actually really easy to do. We're not actually concerned with how this interceptor works internally. We care about how the user sees it, how the user can configure it and make it behave the way they want it to. So it should be reusable. That means having a module that you can install to use it. It should allow its consumers to customize the retry limits, right? Both the global one and for specific domains. And finally, it should be safe to use, right? If you're a user and you drop this thing in your application and you don't set it up correctly, it should tell you at compile time or when your application starts. It shouldn't just silently fail to work. So this is going to be our interceptor. And like I said, we're not too concerned with the implementation. If you're curious, our XJS has a retry operator that makes this kind of a one-liner. So it's not that interesting. We care a lot more about how it's configured. So this is our module. Right now, it's just kind of a template. And we're going to answer the questions of what should it provide and what should its implementation be. And we're actually going to put some code inside the module class, which is not something you often see in Angular. So we're going to fill these in as we explore the capabilities of DI. And we're going to do that through 4 topics. We're going to talk about the tokens, which are the building blocks, then the providers that configure the tokens, the modules which contain and organize the providers, and finally the injectors that we're creating from those modules. So tokens are our building blocks. If you think of injecting dependencies as looking up values in a map, then the tokens are the keys. And because they actually exist in a map at runtime, they have to have runtime values. You can't just use any type like string as a token. And so most tokens we're used to dealing with are just class types, right? We want to inject a service. So they're classes we declare, and they can even be abstract. But there are a lot of things that you can't use directly with DI. You can't provide an interface. You can't provide a primitive type like a string, because those don't have runtime values. And there are a lot of uses where you might want to do that. For example, if you're taking configuration, your configuration is probably a set of primitive values or an interface that represents some object you expect to get. And so we need an interface, some way to mesh them with DI. And in Angular, that comes in the form of injection token. Injection token is the key that allows us to reference and inject an arbitrary type. So in this case, we have an example where we're creating a token for a string type that represents an API endpoint. And we can provide that directly, probably using like the real URL value or looking something up in the environment, and then inject it into the service. And when we're injecting this thing, we can't just say inject a string, because Angular has no idea what string we're talking about. Just the TypeScript type is not enough. So we add this add_inject metadata to the parameter, and that tells Angular which token we want to use to satisfy this injection. So now we can actually get started working on this interceptor. We need to know the number of times we want to retry requests, so we'll provide that with a DI token that we creatively call retries. So with add_inject, our interceptor can configure itself that way and get a hold of this value and use it when it's handling requests. But to see how to configure this, we need to talk a little bit about providers. So we're going to go through the different kinds of providers and then apply what we learn to start filling out our module a bit. So a provider in Angular is a declaration of where the value of a token should come from. And in most cases, we ask Angular to provide us the token by instantiating a class. You can also provide a literal value, or ask Angular to alias the token to another type. And finally, you can take over completely and give Angular a factory function that it will use to create the token. So let's go through a quick example of each of these. So the most common way to provide something is with useClass. And what you're doing with that is asking Angular to instantiate this thing for you by looking at its constructor and injecting all of its dependencies. A lot of the time, though, the class that needs to be instantiated is the same class you're using for the token, right? You don't have a separate interface and implementation. You're just providing a service. And so Angular has some syntactic sugar for expressing that. You just list the class in your array of providers. And so the two that are listed here are actually equivalent. Both specify that retry logging service should be provided by instantiating itself. And the second way you can provide a value for a token is to list it literally. So in this example, we're providing the retries token that we created earlier using the constant value of 3. Right? That's relatively straightforward. Another way to configure a provider that I actually don't see used that often is to specify that it should have the same value as another existing token. Right? And so to do that, you say provide something useExisting. And there's something you should actually be careful about with this in useClass, because the two can look very similar, but they have a major difference in behavior. So take a look at this example. Right? This is using useClass. So the first provider binds this timeout retry service to itself, right? Providing it with itself. So Angular is going to create an instance of it. And the second provider says to provide a different token, retry service, using a class of timeout retry service. So we get a second instance of the service. And that can be a problem because depending on which token you use to inject it, you get different instances of the same service. And if the service happens to be stateful, right, you can have different versions of it in your application in different places, and they don't work together. Right? And you can have really subtle bugs in applications happen this way. I've seen it. And useExisting does not have this problem because it's an alias. We're telling DI not to create something new, but to go look at the existing token and use the same value for the new one. And so we have only one instance of the service here that you can inject using either token. And that's a lot safer to do. So the last way we have of declaring a provider is to tell Angular how it should be constructed directly by providing a factory function. And if you've used factories, you might notice that this is not what you've seen before, where you have export function and you declare the factory function and then reference it in use factory. We're actually using a Lambda here. And finally, in Angular 5, this works. It took forever. And if you want your factory to have arguments, and those arguments to be injected, it's unfortunately not enough to just specify types in TypeScript. You actually have to literally declare out what types your arguments are in this deps array. And so that can be a little annoying, and you can trip up on that. In this case, retry service is using an auth service to get a token from it before it creates it in the factory. So ordinarily, if you provide the same token twice, the one that occurs later in your list of providers will override the one that happens before. But sometimes that's not actually the behavior that you want. You really want to get all of the values that people have provided for one token. And for an example of this, think of the router. Right? With the router, we're able to, in different parts of our application, to import router module for child, specify a bunch of routes, and the router doesn't pick one of them to go with. It actually collects all of them and builds the full routing configuration from all of the individual pieces. And that's called a multi-provider. And they're relatively easy to use. You just have to specify multi to true when you're providing values for tokens. And Angular will take care of collecting them all and injecting them as an array. So here's a pretty simple example of that. We have a token cookie name. We're providing two different values for it, both with use values, so they're literals. And when we inject cookie name, we don't get the last value. We get an array of all the different values. And so now we can begin building out our retry module. The first thing we probably want to do is configure our interceptor. And as it turns out, HTTP client uses a multi-provider to get the list of interceptors. All we have to do is provide this token, HTTP interceptor. We name our class that we want Angular to instantiate for us. And we say multi is true, because there can be more than one interceptor in the application. So Angular will take care of creating an instance of this and every other interceptor, building an array, and injecting it into the HTTP client. Right? That's pretty cool. And next, we probably want to specify a default value for our retries token. So if a user installs this module and doesn't do anything else, they at least get some sensible behavior. So 3 is a pretty good choice. And now anyone who wants to use our interceptor can just import retry module. They probably already are importing HTTP client, because that's what they're using to make requests. And the interceptor will just start working. Right? That's a fairly simple API. But they can also choose to override the behavior if they'd like. If we expose this retries token to them, they can specify their own provider for it. And since it doesn't use a multi-provider, it'll override the value defined in the retry module, because the current module providers override those from the imports. So we've achieved our first goal of making the number of retries configurable. The next goal we had was to set specific retry limits for different domains. And we could do that by requiring the user to provide a token that represents a map. And the map would associate a domain with a specific limit for it, and the user would declare all of that in their application module. But it would be nicer if users could move the configuration for a specific domain right beside where they configure their service that accesses that domain, right? They probably have a module for each API that they access. And just like Angular does HTTP interceptors or routes, we can use our own multi-provider to do this. So the first thing we need is a type to inject. In this case, it's going to be an interface called domain retry limit that specifies the domain and the limit. And we need an injection token for that interface because we can't use the interface directly in DI. If you notice, nothing about this token actually suggests that we're using multi-injection with it. It's completely up to the consumer to decide how to provide it. So with this token, a consumer can specify a value for a particular API domain directly from the module where they configure their API for that domain. So here they have an API module, they're providing some service for it, and they're also saying, for this domain, we want to do 5 retries instead of 3. And that keeps all of the configuration in the user's application for this API in a single module. Right? And that's a really nice property to have. So on the interceptor side, all we have to do is inject this token and tell TypeScript that we're expecting an array. And inside, it'll probably build up the mapping that we talked about earlier and use that whenever requests come through. But what happens if nobody specifies this token, though, right? What happens if the user doesn't want to do any customization? Well, Angular doesn't know about the token, so if we just ask to inject it, we'll get an error, right? Nothing actually provided it. But fortunately, we have a way of telling Angular this dependency is actually optional. We can use this optional metadata marker. And then Angular won't care if it can't find any providers for the token. It'll simply inject null. So we've already talked about modules a little bit as we build out the retry module. But we're going to learn a few more things about them. So we've seen how modules package code for reuse, and also a little bit about how they affect the ordering of providers. And we'll take a look at their role in providing a nice API for user configuration that's better than what we've come up with so far. So firstly, wrapping our retry interceptor into a module does make reusing it very nice, right? All someone has to do is import it into the app module. And we've also seen how it makes it easy to override that provider, because the providers inside app module override the ones that app module is importing. But provider order is not only important in the application itself, it's very important in testing. It's what allows us to have testing modules, for example, a hypothetical mock retry module, that override the providers from our application. So inside of a test, for example, we could disable retry because we know the server is not going to succeed if the test is designed to fail. So our test will run a little faster. However, I'm sure you'll agree with me that this API is not really the nicest that you might imagine. For example, the user has to know that this retries token exists, right? They have to go find that in the documentation somewhere. The token is also configured in a different section of the app module. And there's actually nothing here that indicates that the retries token and the retry module have anything to do with each other, right? And as it turns out, Angular gives us some tools to do a little bit better here. So this is actually what's possible. We can eliminate the need for the user to specify providers directly and hide it behind a static function that they call on the module from their import section. In this case, we've named it with retries. And that's a much cleaner API. It's clear that we're configuring the module. It's discoverable through code completion. And we get much better type safety. So how do we get this, right? What can we do in our module to implement this? Well, the answer is a feature in Angular called a module with providers function. And these are static functions that are typically inside of a module, and they can take parameters. But they're not functions in the sense that they'll be evaluated at runtime. They're instructions to our compiler, and so they have some special rules associated with them. They're the same rules that you see inside of metadata, right? We can't have logic. We can't do operations in code. We can only return an object. And this object specifies a module and a bunch of providers to layer on top. So here's what this looks like implemented in retry module. We declare a static function called with retries. It has a parameter that specifies a default number of retries. And that parameter is used to provide the retries token with use value in the object that we return. And so the interceptor hasn't noticed anything has changed. It's still getting its configuration through DI. But now, the complexity of setting up this provider, right? And this example is simple, but you could imagine something like AngularFire has 5 or 6 parameters that you have to define. The complexity of providing all of those is abstracted away inside the module itself. The consumer only has to call the function, which has really nice type signatures, to import the right configuration. And that's a much better experience, if you ask me. And we can do the exact same thing with our per-domain configuration. So requiring the user to code out this multi-provider is actually even riskier, right? There's a lot more that they could get wrong, especially if they forget to say multi-true and then they override everything that came before it. And this could also be wrapped in one of those module with providers functions. So let's call it retrymodule.customizeDomain. It's going to take two arguments, of course, the domain and the limit. And it can be imported from the API module just like before. There's no harm in importing a module in multiple places. They'll be deduped at runtime. And the implementation is still very similar. Instead of one parameter, we now take two. We bind them in DI just as before, except now the user doesn't have to know about the custom interface that we're dealing with either. Right? We can construct the object that gets bound instead of requiring the user to know how to do that. So even cleaner. And that brings us to our last DI topic of the day, which is injectors. And there are a lot of them running around. So injectors are the runtime interface to DI. You can think of them as a map of tokens to the values for those tokens that were determined by the providers. And a really interesting thing about injectors is that they exist in a hierarchy in Angular. Each injector has a parent. And if an injector doesn't have a token when you ask to inject it, it'll delegate to its parent, and so on up the tree. So it's this hierarchy that I really want to talk to you about. It starts in Angular with something called the platform injector. And this is the top-level injector on any page. And it has in it singleton instances of all of the services which interact with DOM APIs, the location bar, etc. Everything that there's only one of. So no matter how many applications you have running on the page, they're all sharing the same location bar. Right? You can't use the router for 3 applications on the same page without them trying to trip over each other, updating the current location. So that's why the platform injector exists. It represents the singleton state of a page in the browser. And the next level down in the hierarchy is the application injector. And that's a child of the platform. And this is the one that has all the providers from your application module, right? This is the one that gets created when you call Bootstrap module or Bootstrap module factory. And there can be many such applications on a single page, each created from an application module, all of them children of the same platform. So in the hierarchy, it looks like this, right? Pretty simple so far. Platform at the top, application down below. But as it turns out, it gets more complicated. Because when you start lazy loading things, which everyone should be doing in Angular, it gets its own injector, right? When you lazy load a module, that module has its own injector created. And that makes sense. It's a separate piece of code being loaded in, right? It would be strange if we took all of the providers from that lazy module and somehow stuck them in the application that was already running, right? Maybe we have to recreate a few services because their providers changed. That could get complicated really quickly. So it makes sense that when we load new code in, we get a new level in the injector hierarchy. So if you use the router, for example, to display a lazy loaded component, that component class actually gets injected from the lazy injector, not the application. So if the lazy injector doesn't have the token, it'll delegate up to the application, and so on. And you can do some really cool things with that. But it also creates a real problem known as shadowing. So shadowing is what happens when you have multiple providers for the same token in different injectors. And we kind of saw a taste of this with useClass and useExisting, right? If you have multiple instances of the same service, and the service is stateful in some way, especially if it's like broadcasting events that different parts of your application want to listen to, you can get really weird behavior if you have different components injecting different versions of the service, and they can't communicate as a result. So here's what this looks like in our hierarchy. We have an application component, which is injecting retry service, and that comes from the app injector. And so that gets instance A. And we also have a lazy route that's injecting the same service, same token, but it gets its one from the lazy module injector, and the lazy module injector has instance B, right? And that can create really subtle problems. This is really hard to debug, actually. But fortunately, the community has a solution for this in the form of something called a for-root function. And you may have seen these running around and wondering kind of how they work internally. It's just a convention. What it says is this is a module with providers, which only includes providers that should go in the application module. Nobody should ever import one of these things in a lazy loaded context. So here's what our for root would look like if we implemented it in our retry module. We'd still have some providers at the top for things which doesn't really matter, right? Things which are stateless. But the critical providers, for example, setting up our interceptor, that would go in the providers section of for root. And this would work great as long as everyone followed the right rules, right? And only imported for root in their application module and never wrote code like on the right, which is a completely safe assumption because developers always use APIs 100% of the time the way they're meant to be used, right? Everyone reads the documentation. What could possibly happen here? So instead of relying on convention, I suggest you develop your modules to actually check for the conditions that cause problems. For example, you can actually ask Angular if the parent injector and the current injector have two different versions of the same service, right? And if they do, you can complain about it loudly instead of getting your user into a situation where they end up with subtle bugs. So the problem with our retry interceptor is that HTTP client has to be provided in the same injector that we configure the interceptor. Otherwise, it won't see it. And so we need to validate that condition in our retry module so our users get a nice error instead of wondering why their interceptor isn't working. So it's actually relatively easy to do this because modules are allowed to have constructors. And those constructors do get called at runtime. So as long as we inject HTTP client, Angular will make sure that it's provided. So if our user drops in retry module and then isn't using HTTP client, they'll get an error. And we can also tag this injection with this metadata at self. And what at self says is only get this from the current injector, don't go up the hierarchy. So it makes sure that HTTP client exists in the same injector that we're binding our interceptor. And that's much better than failing silently if the user puts the module accidentally somewhere that HTTP client isn't configured. And so with this, we've accomplished all the goals we set out to design Retry Interceptor. It's easy to configure, and it's safe to use. And we still have a little bit more about injectors to cover, but we're going to move on to our next design challenge, which is building a wizard component. So like I said before, a wizard is an orchestrator. It takes a sequence of steps and walks the user through them in order, and prompting them how to complete each step. And once again, we're not really going to care about the implementation of the wizard. We care more about the architecture, right? How do we model a wizard in its steps, and how do they communicate with each other? And in principle, we want this implementation to be as decoupled as possible. Ideally, the wizard should know nothing about the step components except the API that they use, and the steps should have no knowledge of the wizard that they're going to be used in. So here's the API we'd like our wizard to have. It's a component that you can use in a template, and you content project a bunch of steps into it. That's it. It's very clean and very efficient, and sadly impossible. We can almost get there, though. So our wizard implementation is going to start off rather simply. It's a component with a template that just projects everything passed into it. So let's take a look at how we can architect this wizard and its steps, and learn some more about injectors in the process. So as it turns out, beyond the platform, the application, and any lazy-loaded module injectors that you have, there are also injectors in the view. So many times, elements in the view, especially when they have a component attached, will have their own injector. And the hierarchy of those view injectors roughly follows the DOM hierarchy all the way up to the module which loaded that first component in the first place. So to understand this a little more and how it affects component design, we can take a look at how template-driven forms work. So this is a very simple DOM hierarchy for an application with a form. We have a root component, the app component. We have a form inside of that, and one input with an ng model directive. And as it turns out that when you have forms module installed and you're using template-driven forms, this form element actually has a directive applied to it called ng form. And that directive is available for injection by anything inside the form, such as ng model. So here's what this looks like in a chart, right? We have the application module injector, app component has an injector, and form has an injector. And the injector for form has ng form provided. So because input is a child of the form injector, the ng model in input can possibly inject the ng form. And as it turns out, that's exactly how they communicate, right? ng model doesn't get the current form passed in, it injects it. This is simplifying it a little bit, but this kind of implicit component communication that uses DI in the view hierarchy can be very powerful. So let's apply that to design our wizard. So since the step components are projected into the wizard in the view, we can just inject the wizard into each step. But because it's really we want the wizard to talk to the steps, we'll have to have the steps register themselves with the wizard when they're created. Right? So they'll call wizard.registerStep and pass themselves in. So all the wizard has to do is just implement this API. Right? That's easy. Well, not quite, because this doesn't solve the design challenge that we set out to do. Right? This has really strong coupling between the wizard and its steps. Not only does each step know exactly what wizard it's going to be used in, the exact type of the component, but they actually can't work without one. Right? They're required to inject it. So instead, let's move on from talking about DI to talking about queries, and use them to decouple our wizard and its steps. So queries are a mechanism in Angular for reading state out of the view. They work using these 4 annotations, and you place these annotations on component properties: view child, view children, content child, and content children. And they don't use DOM APIs to go query and find elements. They actually result in compile time code generation in AOT. These are bindings that get set up ahead of time, and that means they're very efficient. So to study queries, we're going to simplify our wizard a little bit. Instead of content projecting, we're going to assume that it contains one step that's hard-coded into its view. Right? It's in the wizard's template, not projected in. And since we know the wizard is going to have this child step component, we can create a property step of the right type and add this view child annotation to it. And the annotation tells Angular that we would like to keep this property updated with a reference to the step component that gets created in the view. And unfortunately, that reference isn't going to exist right away. If we try to console log it in the constructor, it'll be undefined. And that's because when this object is being constructed, when this component wizard is, its view has not been created yet. That's a process that happens asynchronously. And so we need a way to wait for Angular to tell us that the view is ready. And we can do this with an event called afterViewInit. So we implement the interface afterViewInit, and then TypeScript will complain at us that we need to implement the method ng-afterViewInit. And it's inside this method that Angular is letting us know the view is ready, and any view queries that you have are good to go. So now we can console log out our reference. But it's important to be careful with this view event, because it's actually change detection which starts creating the view in the first place. So the view is initialized after the first round of change detection has completed. And as you know, Angular has unidirectional data flow, and so we can't change component state after change detection has occurred in the middle of this microtask. We have to actually trigger a set timeout or something and a whole new round of change detection. Otherwise, we get change after checked errors. So just something to be careful about. And as I mentioned before, this view child reference is actually live. We're not only getting the instance when it's first created, it updates if the component changes or goes away. So for example, if this step is behind an ng-if, then whenever the if condition becomes false, the step reference can go to null. And it's also possible to ask Angular to query for an element that doesn't actually have a component or a directive on it. And this is done using the number tag symbol to apply a hashtag-like name to the element. Right? In this case, it's called step. And that's called a reference. And we pass that string to viewChild instead of a component type. And if you notice, what we're getting back from the query is not a component or directive instance, because there isn't one, but actually an element reference, which is Angular's way of talking about an element that doesn't have any other type associated with it. Right? And we can use the element ref to interact natively with the element on the page. But what happens if you have more than one step? For example, if our step component is repeated with an ng4, right, what comes out of this query? Does it give us back an array? Well, unfortunately, no. It only gives us back the first element, right, the first step that gets created. If we want all of them, we have to use an annotation called viewChildren. And that queries for all of the matches to a particular query instead of a single one. And viewChildren returns this thing called a query list. right, which is kind of like an array, but has a few extra options on it. So it has all of the array operators, right? You can call for each or reduce. You can access things by index. If you really need a true array, you can call toArray on it. But the main thing that it does differently is it has a changes property. And changes gives you an observable that emits whenever the view changes. So if that ng4 repeats, for example, right, someone changes the array you're iterating over, and you get new steps created, changes will emit, and we can react to it. So our wizard component can watch the contents of this query in real time and react when new steps are created. Maybe it needs to go, redo some internal state. And the only problem is that these steps we have are configured inside the wizard's view. Right? Can we query for them if they're not in the view, but are instead projected in as we had designed earlier? And it turns out you can do this with content child and content children, which work very similarly to the view queries, but are based on projected content and not templates. And they have their own after content init event that specifies whenever they're ready to use. So we can revert our wizard to its original design of projecting content in for all of its steps. And the users will use it like this. Right? The only thing we have to change is every step component has to be the same one, because that's what we're using to query for them. So with that, the wizard can get a list of all the projected steps and can interact with the API on each step. For example, it can tell every step but the one that the user is currently on to go hide itself. Or it may want to know the title of each step, so it can display the right breadcrumb trail at the top. So this design is getting closer and closer to what we wanted it to be. But it's still annoying in one way, right? Every step component has to be the same, and the wizard knows what they are. But we wanted a design where users could bring their own component and use it as a wizard step, as long as it implements the right API. So let's fix that. And one way to do it is by querying for a directive instead of querying for a component. So for every step, we can apply a directive to it called wizard step. And this is a little bit more verbose than listing the steps without doing anything, but I'd argue that it's actually useful. We're making it clear that we intend these to be treated as steps, and we're opening the door for the wizard to project other content besides just the steps that it wants to process. And this directive doesn't have to do anything at all. Its only job is to exist so that we can query for it. And that's what we'll do. Right? We can query for the directive instead of querying for the step component. And here we're using content children to get a list of instances of it. Right? Who thinks that's going to work? Wow, nobody. We will actually get out a list of all the directive instances. But the directive itself is useless, right? Those are going to be empty objects. We have no way of interacting with the step components, right? We can't even talk to the DOM directly, because we can't get that from the directive. So what we really want is a way to query based on the directive, but get something else back in our list. And we can take advantage of a feature of queries to do just that, and that's called reading. So we passed in a read instruction to view children, or content children, and that allows us to specify that the query should select elements with the wizard step directive, but we really are interested in the element references. Right? We can't read out the component type because the component is different, we don't know what it is. Right? And this is a little more useful. We can manipulate the style of the native element to show or hide steps, but it's still not as good as being able to talk to the API of those components directly. And to do that, we're going to have to do something that's rather unusual. And as it turns out, we can use read with queries to get access to dependency injection from the injector of the element that you're querying for. And we're going to use this fact to finish our wizard. So our plan is to have each wizard step implement an interface. Right? This is a common API that our wizard is going to depend on. And using a DI query, the wizard can then read the service from every step without necessarily knowing what type the step is in the first place. So let's start by defining our service. Right? It's going to be an abstract class because we're going to use it as a DI token. And it has to have all of the methods that we're going to require each step to implement. In this case, we're just doing show and hide, but you can imagine the wizard may have other interests about dependencies between steps or titles or stuff like that. And so anytime we write a step, we're just going to have to implement this wizard step interface. right? That's relatively straightforward. So here's what our wizard is going to do. We're going to query for the step as before, but this time we're going to ask for the injected value of wizard step service instead of the element ref. And that's convenient. That'll get us out a query list of the API to interact with each step. But of course, injecting is only half of the DI story. We also have to provide it. So we need to set up a provider in the step that binds the wizard step service token. And an easy way to do that is to, say, use existing and point it at the component instance that's already in the injector. So we're going from a component that the wizard knows nothing about to an interface that it does, and every step component provides that interface with its own type. And that almost works, except this is actually a TypeScript error, right? We're using step 1 as a value inside the metadata, but it's defined down below when you declare the class. Right? If we're just referencing it as a type, that's OK, but this is one of the few cases where the order of declaration actually matters. And so Angular has a way around this, and it's called forward ref. And what forward ref does is capture the early access inside of a closure, and it evaluates that closure after the class has been defined, and that solves the problem. So with that, we have our finished wizard and step API. So we've explored dependency injection. We built a retry module that's safe to use and convenient to configure. And we used queries to develop a wizard that would use injection to communicate between the wizard and its steps. And finally, we combined queries and dependency injection to decouple the two entirely and to run all communication through them through a common service that we declared right in the view. Right? So thank you very much. That's all I have for you today. If you follow me on Twitter, I will tweet out. Thank you. So I have a link to my slides, and I also have a stack blitz for each example that I've gone through that has the whole thing completely implemented. So I will tweet those out later today. So I'm SYNALX on Twitter. Thank you very much.